Cosmos, Carl Sagan. Heaven and Hell. Venus is a kind of planet-wide catastrophe. It now seems reasonably clear that the high surface temperature comes about through a massive greenhouse effect. Sunlight passes through the atmosphere and clouds of Venus, which are semi-transparent to visible light, and reach the surface. The surface being heated endeavors to radiate back into space. But because Venus is much cooler than the Sun, it emits radiation chiefly in the infrared, rather than the visible region of the spectrum. However, the carbon dioxide and water vapors in the Venus atmospheres are almost perfectly opaque to infrared radiation. The heat of the Sun is efficiently trapped, and the surface temperature rises until the little amount of infrared radiation that trickles out of this massive atmosphere just balance the sunlight absorbed in the lower atmosphere and surface. Our neighboring world turned out to be a dismally unpleasant place, but we will go back to Venus. It's fascinating in its own right. Many mystic heroes and in Greek and Norse mythology, after all, made celebrate efforts to visit hell. There is also much to be learned about our planet comparative heaven by comparing it with hell. The Sphinx, half human, half lion, constructed more than 5,550 years ago. Its face was once crisp and cleanly rendered. It's now softened and blurred by thousands of years of Egyptian desert sandblasting and by occasional rains. In New York City, there is an obelisk called Cleopatra Needle, which came from Egypt. And only about 100 years in the city's Central Park, its inscriptions have been almost totally obliterated because of smog and industrial pollution, chemical erosion like that in the atmosphere of Venus. Erosion on Earth slowly wipes out information, but because they are gradual, the fat of the raindrop, the sting of a sand grain, those processes can be missed. Big structures, such as mountain ranges, survive tens of millions of years. Smaller impact craters, perhaps 100,000, and large-scale human artifacts, only some thousands. In addition to such slow and uniform erosion, destruction also occurs through catastrophe, large and small. The Sphinx is missing a nose. Someone shot it up a moment idle desecration. Some say it was Mameluke Turk, others Napoleonic soldiers. On Venus, on Earth is elsewhere in the solar system, there is evidence for catastrophic destruction, tempered or overwhelmed by slower, more uniform processes. On the Earth, for example, rainfall causing into rivulet, stream, and river of running water, creating huge alluvial basin. On Mars, the remnant of ancient rivers, perhaps arising from beneath the ground. On Io, a moon of Jupiter, what seemed to be broad canal made by flowing liquid sulfur. There are mighty weather systems on the Earth. And in the high atmosphere of Venus and Jupiter, there are sandstorms on Earth and on Mars, lightning on Jupiter and Venus and Earth. Volcanoes inject debris into the atmosphere of the Earth and Io. Internal geographical processes slowly deform the surface of Venus, Mars, Ganymede, and Europa, as well as Earth. Glaciers, proverbial for their slowness, produce major reworking of landscape on the Earth and probably also on Mars. This process need not be constant in time. Most of Europe was once covered with ice. A few million years ago, the present site of the city of Chicago was buried under 3 kilometers of frost. On Mars and elsewhere in the solar system, we see features that could not be produced today. Landscapes carved hundreds of millions or billions of years ago, when the planetary climate was probably very different. There is an additional fact that can alter the landscape and the climate of Earth. Intelligent life able to make major environmental change, like Venus. The Earth also has a greenhouse effect due to its carbon dioxide and water vapor. The global temperature of the Earth would be below the freezing point of water if not for the greenhouse effect. It keeps the ocean liquid and life possible. A little greenhouse is a good thing. Like Venus, the Earth also has about 90 atmospheres of carbon dioxide, but it resides in the crust or limestone and other carbonate, not in the atmosphere. If the Earth were moved only a little closer to the Sun, the temperature would increase slightly. This would drive some of the CO2 out of the surface rocks, generating a strong greenhouse effect, which would in turn incrementally heat the surface further. A hotter surface would vaporize still more carbonate into CO2, and there would be the possibility of the runaway greenhouse effect to very high temperature. This is just what I think happened in the early history of Venus because of Venus's proximity to the Sun. The surface environment of Venus is a warning. Something disastrous can happen to a planet rather like our one. The principal energy source of our present industrial civilization are so-called fossil fuels. We burn wood and oil, coal and natural gas, and in the process release waste gases, principally CO2, into the air. Consequently, the carbon dioxide content of the Earth's atmosphere is increasing dramatically. The possibility of a runaway greenhouse effect suggests that we have to be careful. Even 1 or 2 degree rise in the global temperature can have catastrophic consequences. In the burning of coal and oil and gasoline, you are also putting sulfuric acid into the atmosphere. Like Venus, our stratosphere even now has a substantial mist of tiny sulfuric acid droplets. Our major cities are polluted with noxious molecules. We do not understand the long-term effects of our course of action. But we have also been perturbing the climate of the opposite sense. For hundreds of thousands of years, human beings have been burning and cutting down forests and encouraging domestic animals to graze on and destroy grassland, slash and burn agriculture, industrial tropical deforestation, and overgrazing are rampant today. But forests are darker than grassland. The grassland are darker than deserts. As a consequence, the amount of sunlight has been absorbed by the ground has been declining. and by change in the land use, we are lowering the surface temperature of our planet. Might this cooling increase the size of the polar ice cap, which because it's bright, will reflect still more sunlight from the Earth, further cooling the planet, driving a runaway albino effect? Our lovely blue planet, the Earth, is the only home we know. Venus is too hot, Mars is too cold, but the Earth is just right, a heaven of humans. After all, we evolved here, but our congenial climate may be unstable. You are perturbing our poor planet in serious and contradictory ways. Is there any danger of driving the environment of us toward the planetary head of Venus or the global ice age of Mars? The simple answer is that nobody knows. The study of global climate, the comparison of the Earth with other world, are subject in their earliest stage of development. They are fields that are poorly and grudgingly funded. In our ignorance, we continue to push and pull to pollute the atmosphere and brighten the land, oblivious of the fact that long-term consequences are largely unknown. A few million years ago, we human beings first evolved on Earth. It was already a middle-aged world, 4.6 billion years along from the catastrophes and impetuosity of its use. But we humans now represent a new and perhaps decisive factor. Our intelligence and our technology have given us a power of affect the climate. How will we use this power? Are we willing to tolerate ignorance and complacency in matters that affect the entire human family? Do we value short-term advantage above the welfare of us? Or will we think on longer time scales with concern for our children and our grandchildren to understand and protect the complex life support system of our planet? The Earth is a tiny and fragile world. It needs to be cherished.